what is up? This is Radko Academy and welcome to our channel. In this video, we are going to look at calculus and much more particularly, we'll be looking at second derivative. So, we are going to understand in this video what is second derivative and how can you go about solving a function or a polynomial. How can you be able to differentiate a function two times? Okay. So if you're new to my channel, please don't forget to subscribe to my channel so that each and every single time I post a new video, you'll be notified that we, Radko Academy, we have posted a new video. So let's just get started now. Okay, so now as you can see, we are looking at the second derivative. So this is a symbol that we normally use, second derivative. Okay, so it is d. It is d2y over dx2. Okay, so that's a function, that's a mathematical symbol that we normally use when you want to represent that you are now differentiating for the second time. So now we are going to look at some of the examples that we can use in order for us to understand what we mean by second derivative. So just stick around and get a piece of paper and also a pen or even a pencil so that we get to move together. So now, okay. So I'm going to have the first example. So look at examples. So now we'll be looking at that example. So we want to understand how can you differentiate this kind of an example. How can you differentiate it twice? Okay. So I want to believe that you have understood how can you differentiate a function for the first time or just for a single time. Okay. So now let us see how you can be able to differentiate this function. Okay, so basically we understand that this y is the function of this x. Okay, so what that basically means is that we are going to say that dy, okay, over dx. So dy over dx. Then now we can say that this multiplied by this coefficient, we have 2 times 3, and then x, and then this power will reduce by 1, and then we have on this x there is a power 1, so this 1 multiplied by 1, 3 there, you get 3, and then x, then this power 1 reduces by 1, and then this now constant, just 0. Okay, so those are the basic things that you have to understand. Okay, so now we move on. So this is now going to be, this is 6x, then this is power 2 minus 3. Okay, because this will become 0. Any number to the power 0, any number to the power 0 is 1. So now what's going to happen now is that this is our final answer. This is the first derivative. Okay, so please make sure that you understand how you can get a simple differential. Okay, final answer as in differentiation. Okay, so if you have not understood, make sure you can go over through my videos from Radko Academy YouTube channel. So make sure you also don't forget to subscribe so that each and every single time I post new videos, you'll be actually notified of the updates or the notification that we have posted something new. Okay, so that's basically the first differentiation. Okay, so now our main focus is now to differentiate again this function. The final differentiation that we have gotten, okay, is now to differentiate it again. Okay, so this is going to be d2y over dx2. Now this should be equal to the first differentiation that we did. So this is going to be dy over dx. Okay, dy dx. And then this is going to be 2 multiplied by 6. Okay, x to the power 2 minus 1, okay? And then minus 0, okay? So finally, this is going to be, okay? Finally, this is going to be 12x, okay? So that's our final answer, as in 12x, okay? I hope you have gotten some answers or some understanding of what it means to differentiate a function for the second time, okay? So now let us also jump to the next example and see something that is a bit different, so that we can understand how you can differentiate also something that is a very bit complex somehow. Okay, so now we move on. Okay, so we'll be looking at the second example, okay? So you have y equals to, open bracket, 4x minus 1 to the power 3, okay? So how can you differentiate something which has a higher power, okay? So there is this term in bracket that we need to differentiate, okay? So you can see that it is raised to the power 3. So it's kind of very, cumbersome for you to start now multiplying, 4x minus 1 multiplied by 4x minus 1, again multiplied by 4x minus 1. So there is actually an easier way that we can follow and be able to differentiate with ease, okay? So if you didn't watch my video, please make sure that you go back to the video in which I showed you on how you can differentiate a function with higher power, so that we understand what we are talking about, okay? So what's going to happen first of all is that you have to say that let this u equals to this term inside the bracket, okay? So you let that one equals to that, okay? So once you do that, then you're going to say, therefore, this y equals to, now you can say this in the bracket, so u then to the power 3. Now once you do that, then you can now say dy over, okay, dy, okay. So now you can say dy over dx equals to, dy over du, so this one, okay. So this is going to be now, it's going to be 3, so this power multiplied by that power, the coefficient there. So it's going to be u to the power 2, okay. So you have differentiated that one, okay. And then now the other part, okay, the other part you can do is now this one, okay. You differentiate the function of u with respect to x. So y, okay, so du over dx equals to, this one is just going to be 4, okay. And then now you can combine the two functions, okay. So we can combine the two functions so that we understand what you are talking about. So from there now, we are going to say dy over dx, okay. So dy over dx is going to be dy over du multiplied by du over dx, okay. Now once you do that, this is now going to be, okay, this is now going to be du, dy du is this, then this is going to be that, multiplied by du dx, which is this one, just 4, okay. So now from there now we can say dy over dx, okay, equals to 3u2 then multiplied by 4. Okay? Now from there you can now say 3 open bracket. Now we know that u is this one. Okay? So u is that one. So you say 4x minus 1 to the power 2 multiplied by 4. So you can further now simplify 3 times 4. Okay? And then also multiply by that. Then this is going to be 12 open bracket 4x minus 1 to the power 2. Okay? So what that simply means that we have done actually the first differentiation on this example, or rather on this function. So what you're going to do now, second, is now to differentiate this same final answer now for the second time. Okay, we are going to differentiate that one for the second time. And this is how we are going to do it. Okay, so now we are going to differentiate this one for the second time. Okay, and that's what we call the second derivative. Okay, so the second derivative is going to be something that we introduce as the 2y over the x2. Okay, so the 2y over the x2. Okay, so that's a mathematical symbol for the second differentiation or the second derivative. Okay, so from there we are going to say this is equal to dy over dx. Okay, so now we know that dy dx is this one. Then you're going to say okay. So now this is going to be, okay, this is going to be something that we already know, okay. So this inside is the u function, 4x minus 1, okay. And then we are going to say y equals to 12u to the power 2, okay. And then now we can say that dy du, so dy over du equals to 2 multiplied by 12, then u. Okay. Hope you can see that. Okay. And then now the du over dx is equal to this one, just 4. Okay. So what's going to happen now is that we are going to say this second derivative is going to give us is du over, okay, dy du multiplied by du over dx. Okay, then this is now going to be dy du is which one? Dy du is this one. Okay, so it's 2 multiplied by 12, and then u multiplied by du dx. Du dx is just 4. Okay, so this is going to be 24. Okay, so 24 u multiplied by 4. Okay, so 24u, okay, multiplied by 4. Then now this is going to be 24 open bracket. Now we know that u is this thing over it. So it's 4x minus this multiplied by that. Okay. Now which I can write over that side. Okay. So which is 24 times, okay, 24 times 4, okay, open bracket 4x minus 1, okay. So now from there now this is going to be this is going to be 96. Okay. Okay. So that is the answer for the second derivative. So make sure that we do understand what we mean by that, and make sure that you go through. If you have not understood, make sure that you repeat. You can also inbox me for more clarification, for more, any kind of question that you want. So make sure that you clear that one before you get to the next one. Okay. So now let us look at the final example, and we close the chapter of our second derivative. Okay. Okay, so our last example now, okay. Our last example is C, okay. Y equals to 1 over 2 minus 3x, okay. So when you have something like that, you have to make sure that what you have is, this is a rational function, okay. It's a rational function. So what you have to do is make sure you convert it to something that just get rid, okay, just get rid of this fractional form, okay. So what we're going to do is going to say y equals to 1, okay, and then we're going to take whatever is at the bottom on top, then it's going to become 2 minus 3x, open bracket, then close bracket to the power 1, okay. So the negative 1 implies that this thing is at the bottom of this fraction, okay. Now from there, you can now simply say dy, okay, over dx equals to du over dy over du multiplied by du over dx, okay. That's the formula, okay. And remember, this is something that we did in the previous video, and we call it the combined function. This is the combined function. So make sure you go back the videos if you never understood, if you didn't understand what we mean by combined function or composite functions, okay. So from there now, we are going to say, okay, so dy, okay, over du. So what you need to understand first of all is that you're going to say dy over du will be equal to what? Okay. You're going to say, okay, you're going to say let this thing, okay, so u equals to 2 minus 3x, okay. And then now this is going to be as y equals to u, okay, to the power negative 1, okay. So we get this u and then we put it back there. Remove that one, put u there. Then to the power negative 1. So dy over du equals to negative 1, open bracket u, the power negative 2. Okay. Or if you like, okay, if you like, you can say negative 1, maybe just say negative u to the power negative 2. Okay. And then also now, okay, du over dx. Okay. What is du over dx? So du over dx is going to be now, we know du over dx. So u is the function of x. So this is going to be 0 minus 3. Okay. And the 0 minus 3, this is just going to be give us negative 3. Okay. So we are going to actually need this function derivative and also this derivative. Okay. So over that side now, what you do now, okay, so dy, du, okay, is this one. So negative u to the power 2, okay? Negative 2 to the power, negative u to the power negative 2 multiplied by du dx, which is just negative 3, okay, which is just negative 3. So du dx is just negative 3. So multiplied by negative 3. Now we know that u, okay, is that we made it, okay, an assumption, say u is that one. So we substitute now. So negative, open bracket, 2 minus 3 minus 3x, okay? So negative, open bracket, 2 minus 3 x to the power negative 2 multiplied by negative 3, okay? So from there now, we can just even say just this is 1, okay? So this 3, okay, this negative 3 and negative 1 will give us just 3, then open brackets 2 minus 3x to the power negative 2, okay? So now from there, we can conclude, say we have this one as the final answer, okay? Now remember that the answer that you have just given over there is just the, is just the answer for the first derivative. But our question is to find the second derivative, okay? That's our main goal. So after that now, we are going to say, okay, so the 2y over the x2 equals to dy over the x, okay? And this is now going to be, you know that this is, okay. So what's going to happen again is that this is u, okay? That is u, so this is going to be like, you can say that u equals to 3 minus 2x, okay? And then y will be equal to 3u, okay? To the power that, okay? So make sure you understand that. So from there now, dy over dx, okay? Dy over du, okay? This part is going to be 3 multiplied by negative 2, and then u, okay? To the power negative 3, okay? So this is going to be negative 6x, 6x, okay? Sorry, negative 6 u to the power negative 3, okay? So that is that, and then now from there we can have another function, du over dx, okay, which is just negative 2, okay. Now from there we can say this is going to be dy, okay, over du multiplied by du over dx, okay. Now from there we can have dy over du, or du equals to negative 6u to the power negative 3 multiplied by du dx, that's negative 2, okay. So this is going to be now negative 6, open bracket, u, we know that u is this one, okay. So we substitute 2 minus 3x, okay, to the power negative 3 multiplied by negative 2, okay. So from there now, we can have negative 2 multiplied by negative this, and then dot 2 minus 3x to the power minus that. Then this is 12, okay? So this is going to be 12, open bracket, 2 minus 3x to the power that, okay? And that's a function, and that's the final second derivative, okay? So thanks so much, guys, and this is how you can go about finding the derivatives of the second derivatives of different functions of polynomials. So make sure that you go through, okay, you understand the key concept in our second derivative on how you can find it. So thank you so much, and this is a Radical Academy. If you have not subscribed to my channel, make sure you do subscribe to my channel so that whenever we do something like this, you'll be actually notified once we post them to this channel. Thank you so much, and I will see you in the next video.